Hello everyone. This talk is about the physical properties of AGN outflows and their impact on host galaxies. So first of all, there are several reasons why we need AGN feedback to quench star formation in massive galaxies. The problem is we still do not have convincing observational evidence that AGN outflows are effectively quenching star formation. So first of all, this is an example of what we have done in the high redshift part. I would like to focus you just on these figures, and on the left you can find the kinematical maps, the velocity maps that you get from the oxygen 3 emission of two high redshift quasars, and you clearly see that you detect two conical outflows. Now, in the central panels, you see the narrow H-alpha emission, which is powered by star formation. You get this by getting the total spectrum, subtracted the broad and the narrow line emission that is due to the AGN. What you are left is a narrow H-alpha emission, which is powered by star formation. On the right panel, you can find the maps of this narrow H-alpha emission, which is powered by star formation, and the white contours represent the highest outflow velocities. Clearly, you see an anti-correlation between the highest outflow velocities and the presence of star formation, which is basically what you would expect to see. However, you have to take into account that even if there is this anti-correlation, star formation in the host galaxies is still significant, over 100 solar masses per year. So we are still not seeing outflow, which are totally quenching star formation, and similar results are found by the Supermassive, which we conducted over a sample of AGN at this intermediate redshift. Now, coming to the low redshift universe, we are conducting the Magnum Survey, which is targeting nearby AGN, which allows us to have, on one hand, a very high intrinsic spatial resolution of the sources. On the other hand, there is a wealth of multi-wavelength data available. Just a couple of highlights from this survey. First of all, this paper that from Giacomo Venturi et al., which just came out on the AstroPH. And what we find in these galaxies, you have conical outflows, which are clearly detected in the oxygen 3. Now, in the outflow, you would expect that the highest velocity dispersion of the gas is mapping the outflow itself. However, in these galaxies where you have a radio jet, you basically found this structure, which is very narrow and perpendicular to the radio jet and to the outflow. The interpretation of this is not trivial, and indeed you can find some discussion in the paper by Giacomo, which came out on AstroPH. Now, another paper by Matilde Mingozzi, it concerns the study of the physical properties of the outflow. Among the many results that we obtained, an important one is that basically, we find that the highest ionization of the outflow is in the inner region of the outflow. That is, at the edges of the conical outflow, you have the low ionization, and in the central part, you have the highest ionization. This is basically related to the outflow structure that we see in kinematics. So you see clearly these features in these two galaxies, where you have blue velocities on the edges of the cone and a red velocity at the center of the cone. This can be interpreted with a conical outflow. Indeed, if you do a simple model, you can find again these features. However, the observed velocities are much more complex than the model, the simple model that we can do. So we can question whether this is the effect of real motion or the effect of a clumpy line emission. Now, this is why we developed a new approach to kinematical modeling, which basically uses the observed flux distribution to weight model velocities. And this is an example of what we get. These are observed data from the same two galaxies, and here are the results, the model. I don't have time to enter into the details here, but what happens is with the right cone geometry and outflow velocity, the model is able to reproduce the observation. And this is just telling us that the observed kinematics is consistent with simple radial outflows with constant velocity. And all the other complexity is due to the clumpy line gas emission. My time is over, so these are my conclusions. Outflows are impacting host galaxies, but their overall effects are apparently not significant. Thank you.